So to finish up our swarming project, we're going to actually look at how we can use the same kind of techniques with the flock modifier to swarm creatures all over a surface. So we're going to have some bugs kind of creeping over a surface, and we're going to use the XP follow surface mod to stick them to the surface or to have them follow the surface. And we're also going to look at some sort of limitations that arise from this kind of technique and how we can get around them. And also just, we're going to pump the level of creatures up so it's a pretty dense, scary looking swarm. All right, so we're going to start the scene from a similar place that we started the taking flight section, where we kind of had a flying beetle, and we've got the same bug, except he's got a new paint job and also he's closed his wings. So, or maybe he's lost his wings. I don't know. Either way, he's a crawling one and he has a walk cycle animation. And I'm going to start again from where we did exactly what we did in the last one, which was to prepare the asset for looping animation. And just sort of to drive that idea home. So what do we got? We've got some animation every keyframe for 59 frames. If I bring up our timeline, we can see that it's a PLA a PLA track, and we need to remap this. So I'm gonna add a time track. So I'm gonna right click. I'm going to add special tracks, time track, and then I'm going to click on the PLA track, and I'm going to pick this new time track as the time track to map to. This is so that we can create the loops. So I'm going to click on the time track, go down here to our attributes manager, or you can even do it up here. You can go to functions, track after, and then you can click repeat after, but then you're still going to need to go down here to increase the number of repetitions. So let me just close this down, and let's extend the timeline to let's do 1,000 frames, something crazy. And you'll notice that it repeats once at the moment and then stops animating. So we need to extend that, and I'm just going to put tons of zeros until we get to that maximum number. And that should loop forever now without issue. Okay, if we wanted to kind of tweak this, we could actually increase the speed by reducing this time track. This is a really good way to retime your animations, by the way, if you need to do it in a kind of a quick way. So that's a fun way to do it. You can do slow motion as well, so it interpolates the points. It's really nice. But we want to leave it at default because we can handle all that stuff in the actual XP generator. Okay, so obviously we need to add another system into the scene. And let's call this one, I don't know, surface creepers. We know what that means. So let's change the color, as is tradition. And let's take the icon off. And let's start adding stuff that we need. So we know that we need an emitter. We need a follow surface modifier. We need a flock modifier. And also an XP generator. So I'm going to, on the XP system object, I'm going to go, right, holding command or control down, generator, emitter. Emitters in generators, in the generators section, by the way, because it generates particles. Then we need what did I say? Oh yeah, that was it. The obvious ones. Follow surface and flock. So where are we? Flocking. There we go. Now I actually know that with these setups, we're going to use something else later on, which is constraints. And this is a really, really cool dynamics system thing, where you can kind of have relationships between the particles and they kind of have effects on each other. And I'm going to add one, but I won't tell you what we're going to do with it just yet. I'm just going to bring it in later and we'll talk about it when we come across it. So let's start by adding our geometry into our XP generator. And then let's associate this XP generator with the emitter that we want to use, which is this one. And I'm going to tweak some settings in the emitter itself. So let's go to the emitter. Let's go to object. And let's, in fact, actually, we can just use we can go to the viewport and do this in here. I want a thin line that I'm going to emit out like this. I'm going to make it really thin like that. I could use the defined emission mode, which is like a cloner. It's almost like a cloner, you see, so it has this very even sort of thing, but it's a bit harder to control the rate. You get this single emission like this. I'm going to actually turn off the flock modifier for a minute to get that weird stuff going on. You see it emits one particle per box, if you like. And then I could have it a constant stream, but it's hard to control the amount that's coming out there. So I'm going to go back to my rectangle. And I'm going to turn off the generator for a second. Let's just have a look at the particles themselves. And we could hide our baked beetle. Sorry for baking you, beetle. And let's change the display to something that shows both radius and direction, which was the pyramid. That's nice. If we have to zoom in a bit to see that. There we go. Going way too fast. I think we'll start with a very low speed. I might even take the speed off altogether later on because the flocking can completely deal with that. I want to make the radius a touch bigger, and I want to massively reduce the number we're emitting because at the moment there's just way too many. There we go, maybe 50. And I don't want them colliding, so we use no intersection. So this is on a mission. It won't emit if there's a particle in the way. Let's just give it a bit more speed so they clear away quicker. Let's go for 30. There we go. So I'm just making sure they're not emitting within each other, just causes issues later on. And that's pretty good. Let's perhaps give them a random color from the gradient. Let's try multicolored like this. Cool. And let's next up add a surface. Let's go for a plane, and let's throw on. Let's first of all give it some decent size. We don't want to go too dense. The only thing with sort of the modifiers and the surface modifiers is if the geometry is really dense, it can get really slow on the emitter. So we need to be a bit careful about how many there are, but we need enough to allow us to deform it. So make sure I can see the wires. There we go. Shortcut for that is NB. So that's just quick for Gouraud shading lines. And also make sure that you're in wireframe mode so that you can see, because in Isopalms mode it looks like you've got less subdivisions. It's just one that catches some people out sometimes. So we're in wireframe mode here, and I'm going to go 50 by 50, and then I'm going to add a deformer. So I want to use a displacer. So I held shift down there whilst I had hold of this, so that the displacer became the child of this this plane. And let's give it some interesting. Let's give it a noise. So in the shading tab of the displacer, add a noise. We're going to make it huge. Let's see how big we can go. Let's go to 2000. There we go. And let's increase the amount. So in the object tab, raise it up like this. And there's a couple of reasons we have to be a bit careful about how aggressive this is, because if it's too aggressive, the particles tend to flip over, and there's no way to correct that at the moment because there's no access to having an up vector on each particle where we can kind of keep them upright. You can kind of, the smoother the kind of surface, the better, but it's just good to prepare it to start with. Do you know what? I might make this noise a little bit larger. So back into the noise. There we go. Pretty cool. And perhaps we should give it some obstacles as well. So let's throw a few cylinders. Let's go for. And this is going to be what we're going to put in the flock modifier as a void objects. So I'm holding Control or Command when I'm clicking on this axis handle here and just dragging, and that duplicates them nice and quick for us. All right, let's make this one a little bit bigger. Maybe make this one a bit bigger as well. And we can go back to Isopalms mode. This looks a little bit cleaner. Actually, it kind of shows off the... Let's just go to a non-wireframe mode. Let's group those up. Let's just call it objects. Oops. Plural. And I'm going to throw that into other objects there just so that we've got it stashed away in the system. Especially useful if you're going to save it as a preset. So at the moment, these particles are not following anything. They're not doing any... There's no modifiers active. If I activate the follow surface, nothing happens because we need to tell it which surface to look for. And that's our plane surface here. So if I actually have a look at this, let's increase the speed of the particles. Let's give A bit of variation just to make it a bit more interesting. And you'll see as they, although that might not be completely apparent, they are actually following the surface. I'll tell you what would help. In fact, there you go. They're definitely following it because they can't get off the edge. Let's add a trail object. So trail, throw that in the generators section there. Oh, I've hidden it, that's why. Inadvertently did that. You can see now it's following the surface, and each particle has its own trail, so you can see where it's coming from. And this is really cool. So it's restricting it to this surface. It's like it's clamping it to the surface. Now, obviously, we haven't got the flocking behavior on there yet. So let's actually, before I do that, let's just have a look at the orientation of the particles. If you remember in the first one, we looked at how to make them tangential to make sure they're facing the right direction. You know, they're facing the direction they want to go in. Let's just throw a turbulence mod on. And let's increase the strength quite a lot. Go back here. And you can see here, if I go underneath, you can just see the bottoms of them just sliding around, but they don't go through the surface. They just stay stuck to it. Now you see these ones are escaping because they're getting to a point that the XP calculation is actually not fine. It's too coarse for the follow surface mod to keep them on the surface, so they're going too fast and they escape basically. So there's other ways to kind of keep them on the surface if we need to, but we're not going to actually ever go to the edges, or if we do, it's not going to be a problem. If you look here, they probably still escape, but I've activated this accurate checkbox here, and that keeps them on as well. That just means it's sampling the surface very accurately, but it can be a bit slower. But I'm going to leave it on for now, see what happens. So that's our basic follow surface stuff. We've got that down, but you'll notice, by the way, the particle directions aren't rotating as they should. So we need to activate that in the emitter. So let's go to the emitter, go to the extended data tab, activate use rotation, and change it to tangential. Now you also need persist orientation on, because what that means is without it on, it will take the, so if you're firing off the particles in all different directions from the start, say let me turn off the turbulence, and let's go to our object tab, and let's make our emission angle. Can you see that? It's firing them off in all different directions. Now, if I had if I turn off persist orientation, what's going to happen is it'll use that first emission direction, and then if we put the turbulence mod and it changes direction, that won't correct the rotation. You'll see can you see this one here? That should be facing the opposite direction, but it's just using the initial emitted direction. So we need persist orientation on. And here we go. We'll see them rotate, and you can see it's facing the right direction. So there we go. That's tangential. Always useful to know that. And it's how we're going to have our creatures facing the right direction, as we had in the earlier tutorial. So next up, we're going to deal with the actual flocking. So we've got our let's turn the turbulence off actually. Here we go. They're starting to sort of behave a bit more like a flock. And we need to add our avoid objects in. So this is all going over stuff we've already done in the first one. I just wanted to do it all from scratch again, just to let us, refresh us basically. So I've added the cylinders to the objects tab, and I'm going to increase the avoidance weight maybe a touch. And we'll see our little particles, our little boids kind of behaving around each other, flocking around each other. That's awesome. Let's change some settings in there here. Let's go and let's restrict the max speed to, say, 150, because our critters are going to be able to go fast, but they're not going to be able to go that fast. So let's perhaps increase our separation strength. They're actually returning to the emitter because they see it kind of turns them around, and then you end up with the bulk coming back to the emitter. If we really want to show it off, we need to actually stop emitting at some point. Or we could do a pulse emission where we kind of emit a row of boids or creatures, and then we wait a few frames, and then we emit some more. That might be quite cool, so let's try that out. Let's go to pulse. So in the emission parameters, we change the emission mode to pulse, which basically emits a bunch of particles for a certain length of time, every interval of X frames. So currently it's 30. Let's change it to 60. So there we go, you get a pulse, and then a pulse, and then a pulse, and so on. They're still not escaping, so perhaps we need an attractor to tempt them over to this direction here. Let's just hide this displacer, by the way. There we go. And let's give our objects sort of a uniform material, just so we can kind of separate them out. Some nice colors. Possibly not nice. That looks too much like water. There we go. It's a sandy surface, maybe. So, okay, we've got them coming out. We need to actually kind of attract them over to this area, because currently they're kind of returning to sender. And let's chuck a flock helper in. So let's type flock, and we will get this XP flock helper. Let's make it a child of the flock. It's not necessary to do that, but I just like to do it because it's nice and tidy and there's no harm. So it's currently set to attract mode, and it's got an infinite fall off, or an infinite effect. It's not only limited to a sphere or anything like that. And that should drag us a little bit over here. Yeah, it's kind of tempting them in, but they are trying to stick together pretty heavily. So let's so I'm going to turn off accurate on the follow surface. There might be a bit of friction going on. No. I'll leave it as it was. That's fine. It's probably, let's see what we've got. So we're not letting them get to their higher speeds. Perhaps that's what's the issue. That's looking a little better. Increase the cohesion strength. And also let's match the velocity a touch, because we want them to kind of move a little bit more uniformly, perhaps. There we go. That's pretty cool. And then we can increase the attractor strength as well to kind of pull them away from their source. There we go. So you can see them getting dragged in now. And we could probably add a few more here, because we haven't got many particles emitting at the moment. Let's we can increase the size of the emitter a touch. Let's just lift it up, make sure it's not intersecting with the surface. Go to the emission tab, and let's go for 100 per emission, and maybe we'll drop the no intersection radius down a touch, because at the moment there's only a few particles per emission. So that's looking pretty cool. And you can see with the matching strength, you get this very uniform movement. So perhaps we need to mess around with some chaos. There we go, get some troublemakers going in there. Drop the match strength velocity down a touch. And you'll find yourself, like with all of these projects, you'll find yourself tweaking these things over and over to work out what you kind of want to do, what you kind of want to work out, and what gives the best effect. I quite like having a high separation strength, actually, because it seems to give a nice look. So here we go. So you see they're gliding across the surface. They are sticking to the surface as they move. It's a bit hard to see there. There we go. It'll be much more obvious when I put the creatures back on. So let's do that now. So let's put our creature back on, and the first thing we're going to have to deal with is scale. So let's nudge it on. And you can see they are absolutely massive. Too big, obviously. Let's, instead of using the emitter to set the scale, let's use the generator this time. So we can set the scale using down here in the generator. And I can go to set scale, 0.1, 0.1, 0.1. Let's go back a frame. Let's just nudge it one. There we go. We're starting to see them come in a bit smaller. But I want to see the particles as well, because the particles will show off our radius. Yeah, that's actually not too bad. I might leave them... Yeah, I might leave them at that size. That's pretty nice. And you'll notice that also that they are offset. So currently they're not at the center of the particle, which is actually here. So we need to create an offset. So all we need to do is group or add our beetle to a null. And then we can go into axis mode over here and move it up on the y-axis. And you can see that we can center our bug onto the surface. Or onto the particle, I should say. Okay, that's pretty cool. Let's press play. Playback's a little bit slow because I'm not in... I need to go into one of the render instance mode. Oh, we need to hide our original bug, so make sure he's Oops. Still in access mode. Caught me out there. Make sure he's out of sight. Luckily, we've got a surface we can hide him under. Okay, let's press play. And there we go. We get these little critters scattering across the surface. This is going to be pretty cool. Pretty horrifying as well. Carrying these weird pyramid shapes with them too. So let's turn off the particle display. And we're starting to see something resembling a crowd simulation. And their movement is dictated by the flock. So they're going to move together as much as you tell them to, or they're going to like separate and go run around a bit chaotically. The flock helper's static, which I don't think is very useful. So let's just throw a vibrate tag on. Let's give it some. I'm going to give it some motion, and I'm going to make it quite a slow moving one. So just to keep them moving away from each other, because you don't want them sort of clustering up for too long. Give them a bit more purpose, perhaps. Let's make it even different seed, just to see what goes on. And you can see the playback is dropped to well below 10 frames a second. If you need perfectly smooth playback, even when you've got render instances on, you need to go back to one of the particle display modes. So we need to go to particles only, and we'll get some smooth playback back. Or even just deactivating the generator would be the best option, actually. Here we go. So they're flocking as they should do, and they're also adhering to the surface. Next up, we should probably deal with the collisions. So currently, because of the flocking, it deals with the overall separation of the group. It's not a collision simulation. It's a very coarse simulation where it's sort of more of a rule than a law, more like guidelines than a law, I guess, where they have a percentage amount of they're told to move away from each other. They can still bump into each other and cross through each other. So we need to deal with that. And one way you could do that is with collisions. And particle to particle collisions seems like the best option to start with. Let's just try that out actually. Let's put the generator back on so we can see things. Let's change the display mode to geometry only. And let's have a look at all these creepy critters. And you can see tons of them are actually intersecting. And the reason for this is that, like I said, the flock modifier is not a collision system. It's a rule system, and it's not like they can still cross through each other, and you end up with these intersections. So I'm going to need to do something. So let's add this collision object, and it's called P2P collisions, which is particle to particle collisions. And let's turn off the bounce because I don't want any bounce. And let's see what happens. So yeah, this is working actually, So look, if you look, they're kind of bumping into each other and they're avoiding each other. So this is actually pretty nice. However, you can see there's this weird situation going on where they're flitting really fast. They're kind of, as soon as they bump into stuff, they kind of flick into a different direction. And that's not very smooth, not very organic. These guys are flipping. That is actually something that will happen, not just with the collisions. And we'll deal with that later. We'll have to kill them off or something. But you can see it's kind of made it look a lot more authentic. They're colliding with each other. They won't intersect with each other. And it's really enhancing this flocking behavior. But like I said, you get this kind of weird jittering going on. So the solution to this is a bit of a trick using constraints. And we're going to apply a force to the particles rather than an actual heavy collision. And let's delete our particle-to-particle collisions and go to our constraint object and activate it. And let's go back to the beginning. Let's press play. Now, default, nothing's going to happen because we've got no constraints active. So if you look through all these tabs, we have all this amazing stuff. So we have basically a constraint is a particle-to-particle force or restriction. So one particle will look around itself based on the rules that you set, and it'll say, should I make a connection with this particle near me? And should it be a rigid one or a one that can break? How many particles shall I connect to? That kind of thing. And if I just put connect on birth on, and I actually go to our emitter, and I put display, and I do display constraints, oops, there we go. We can actually see what's going to go on here. Oh, I need to actually display the particles. So there we go. Now you can see these yellow lines. that basically means these particles are sticking together. So if we look here, they won't actually separate, and they'll connect with other ones as they get closer, and you can see we get a cluster of them going on. So basically it means that they can't now separate themselves. This is just an example of the constraint system, and it's awesome. We'll actually use a bit of this stuff in the FUI, future user interface stuff. So this isn't actually the part we want to use. We actually want to use this one, which is forces. And we'll also maybe use collisions depending on how successful forces works. And forces is going to allow us to apply a attraction or repulsion force to our particles. But it's not a collision. So if I actually look at default, it's actually got attraction and repulsion set the same. I'll tell you what, the display mode isn't actually very useful. So I'm going to go back to showing the bugs themselves. And I'm going to go to the constraints modifier. These are modifiers, by the way. They're just dynamic modifiers. So they have their own tab here. Or null, sorry. So we don't want attraction really, but we want some because that's fine. And you often need to have a little bit of one or the other to get the other to work. So they need to balance each other out a touch. So just keep some attraction on, but make the repulsion something higher. And increase the distance, and you'll start to see they start to avoid each other, but they don't. It's not like a really harsh, sudden flick. Some of them are because they're hitting pretty hard. But we can increase the strength, and you can see it's a much smoother operation than we were having with the collisions. Now we're still having the issue of the flipping bugs. And we can deal with that. That's kind of why I coloured him with the belly, the different colour of the shell, because I wanted to demonstrate this effect where things flip over. So that's pretty cool. We've sorted out a couple of issues here. So we've sorted out the colliding, and we've also sorted out the movement. I'll tell you what we haven't actually looked at is the speed of the animation. Let's go back here. Let's just double check that our time is repeating. Yep, that's all good. And let's have a look at the I'll tell you what, then because they're render instances, we need to actually have them off. Oh, it doesn't look like it's actually. Let's double check. The animation doesn't look like it's playing, perhaps. Oh, there we go. It is. I just needed to speed it up massively. Of course, because it was quite a slow motion animation to start with. The scale of the animation I needed to increase hugely. But now we're getting the creatures kind of. Could even go higher than that, perhaps. So here they come. And you can see them scuttling along. Pretty disgusting. And if they're offset from the surface, so if they're actually floating above the surface, let's have a look at that. Yeah, they are. So there's a couple of ways we can fix this. We could use the offset that we created in the in this null, with this null, or we could use the follow surface modifier, and you can actually use this offset parameter. So if I offset them by -2, I want to have it so their feet are just coming under the surface. So let's have a look, see what we can get. Bit too much perhaps, so somewhere in between, 4.5 maybe. You'll constantly be tweaking these parameters, definitely. But that's not too bad. I just want to make sure they look like they have contact with the surface. And perhaps if we put a light in here with a shadow on it, that would really sell it. So let's just put a viewport light. We're not going to be rendering this one. This is just for viewport goodness. Let's throw another light in. And let's make it, I don't know, a bit of a cooler colour. And drop the shadow off that one. I don't want the shadow on there. Drop it down. There we go. Bit of lighting for us. And the shadows. So you can see these awesome looking little creatures, and off they go. Definitely making contact with the surface, which is good. And away they go. Now obviously our playback speed has diminished somewhat dramatically. Yeah, this little dude just floating up here. Wonder what's gone on there. So he's probably been caught by the surface modifier, the follow surface modifier, but he's maybe he hasn't been caught by the surface. This distance value is the distance at which it'll be captured by the follow surface. So you need to have that at as long as the particles come within 30 centimeters of the surface, they should be okay. Although this guy, he seems to like to climb up. There he goes. He's back on the surface. Awesome. Okay, so we're getting somewhere with this. This is looking pretty cool. Let me go back to our render instances because this is really slow for me right now. And you want some semblance of real time. It's close. It's not quite, but there we go. Now, there was one other issue we saw earlier, and let's see if we can find one of them. And that is flipping bugs. That's not a exclamation. That's just a fact. Oh, I saw one. So over here, we can see something that goes on. And there's an issue with... Currently, there's no way to set an up vector for these particles' rotation, which is a bit of a shame, but it's just a limitation to be aware of. And we can deal with this in another way. So what I can do is I can test the particles. I can question them and see how far they're rotated over. And if they're rotated too far over, I can delete them or I can freeze them. I could even change their group and replace them with a dead bug or something like that, right? For now, I think we'll just probably kill them off, which is probably the easiest way. Or we could scale them down even just to kind of make them fade away quickly. Oh, we've definitely got a flipped one over here. Poor little dude. So let's start thinking about how we can do this. So we need a question and action set up. So we need to question the particles and say, hey, what rotation are you? Are you within this rotation range? If you are, do this action. So that's really easy to set up. A little bit hard to understand to start with, but you're going to want to get your head around this eventually because it's really powerful to be able to query particles and get an action. And you can even have sub-questions. So you can have this question only act on particles of... So you can say greater than X age and also are flipped. So you could say as long as they're older than 10 frames and they're flipped, do the action. Otherwise, don't do anything. So let's go to our emitter and go to our questions tab and let's add us a question. Let's minimize all these and only keep these open. Let's just put this in there. Tidy up our scene. Lighting, there we go. So in our default question is particle age, right? And I'll tell you what I'm going to do is I'm actually going to turn off our generator and just look at the particles. Here we go, off they go. And what we can do is we can add an action. So currently it's set to, the rule is set to look at the particle data age, which mode, whether it's greater than, less than, equals, or is within time of death, in range, that kind of thing. So if I say, is it greater than 20, nothing will happen apart from the question will be answered and nothing will happen. But I need to add an action. So currently the default action is an editor display. And this is the best way to make sure that your question is working. And you need to activate change editor display and change it to like, I don't know. Let's change it to arrows for filled and change the color to white. So basically, as long as our particles go above, or when our particles go above 30 frames in age, or let's do 60 because it's a bit quick otherwise. And let's press play. They should change their display mode. And they do. So you see that happened. And because our emission is a pulse mode, they are all emitted at the same time. So they become 30 frames in age at exactly the same time. Okay, we don't want it to be... So we don't want to have a look at the particle age. We want to look at the particle rotation. And we need to put our generator back on because that won't... Otherwise we won't see our flipping bugs. So we're going to change it from particle age to rotation. And this is also particle data. So particle data, the particle data we want to question is rotation, and we want to check if it's rotated on bank. So we want to check if it's rolled over, basically. So bank is the roll kind of axis. And we want to make sure that we know that it's within a range of turned over or upside down. So what I'm going to do is I'm going to set it to is in range. I'm going to set the rotation amount to 180. Which means it's going to start looking from the upside down. So it's as the creature is flipped upside down. Let's just do this with the camera. Oh no, that's not a pleasant experience. There we go. So he's upside down, 180 degrees, and then we need to check how far he's going to be rotated to like what range. So we need to go quite far on this. So 120 maybe. Just going to look either side of 180 to look if he's rotated. And this isn't insanely obvious until I actually bring back the large number of them, get them crashing. I'm just going to hide the lights for a second just so we've got no shadows slowing things down. Oh, and I just realized, and we're still in editor display mode, so basically we need to change that from editor display mode to something else. So let's change it to a freeze action. Oh no, actually, let's not freeze them. Let's kill them. I think that's a better idea. So let's change it. So we're changing the action now. So the action that's occurring is going to be a change life, which is a direct action on the particles. Change life. We don't want to change the editor display. That, well, it's not going to make a difference because we're going to kill them. So definitely doesn't need to be on. And then we can have a look at the operation, and the operation is to kill the particle. So if the question or the query is matched, it will just instantly kill the particle. So let's play. We actually have to find one that actually flips first. So I'll tell you what, let's turn our questions off because otherwise it's going to take ages to find one. Oh, there we go. So there's one here, right? So here he is. Now if I play on, he's just going to carry on moving upside down. Obviously that's not very good. If I turn the question back on, let's see if that actually affects. So let's have a look at him. Boom, he's gone. So basically the question is now going to eliminate any bug that flips or comes within a sort of certain level of flipping. Let's see if we see any flipping now. And because our simulation, we're going to actually view it from a distance because there's going to be tons of these little critters. We don't need to worry about, killing a few off. See, you can't see any bellies, can't see any upside down critters. I'm sorry, upside down critters, you're not allowed in our universe. And so this is excellent. So this is the cool thing about X-Particles is you can layer up these questions as well and, really specifically address certain particles and filter them out based on those parameters or that question. And it gives you so much control that, even with layering on sort of modifiers and everything, that's a whole level of control. And then the question system is an even bigger level of control. And then back in the modifiers, you can map things. So we could map, the color of these over time or depending on their speed, that kind of thing. It's awesome. So, okay, I think we're pretty much done with our surface setup and our surface critters. Let's just do one sort of last thing, which is just to increase the number of them and see how many they can handle. And you'll notice I'm in render instance mode, so we don't get the nice random offset animation. However, that's not such a bad thing because they are in sync. So basically that means that their legs, if you look at all of them, they are identical. So that's not so great, but if you're far away, maybe that's not going to be too much of a problem. Hello, is this one? Did I find one rogue one? Oh, he's starting to. I think he might end up getting vanished. Oh no, he's surviving. So we've got a wonky one, but he'll be all right because we're going to view it from up here, so it doesn't matter. But so like I was saying, we can have the generator set back to straight clone mode, so we get the nice and turn random offset on, and we can animate them, but immediately you see my viewport can barely move right now. So you'd only really do this on the very last moment, and you'd when you're going to render, but it would look awesome. So I might do that as a little kind of viewport render just to demonstrate. Let's go back to render instances just so that we get a bit of playback. Let's go back to the emitter, and let's emit over a longer length, and let's do a few more bugs. Yeah, there's still quite a few, not that many coming in. What if I increase the height of this bad boy? And I'm going to have to, it's probably not going to capture all of them, the follow surface. So there you go, look. So they're flocking with their mates, but they're not getting pulled down to the surface. So let's increase the distance they get pulled down. Do you see them getting dragged down to the surface? That's quite cool. And we can use this friction parameter here, by the way. You can actually kind of give them some resistance. So you see here, they struggle to move. That might be a nice way to just multiply the speed. Look at these horrible little critters. So let's get some interesting camera angles. Oh my goodness, that kind of made me cringe a little bit. So we've done multiple things here. We've created a crowd simulation, and you could use all sorts of creatures. You could use humans running, that kind of thing. Although the flipping might look a little bit weirder with humans. Let's hope in the future we get some kind of up vector capability in the generator or in the particles themselves. That'd be much appreciated. But for now we can get away with quite a few of these little guys. Let's go for even more if we can. Let's make sure they're getting captured. There we go. Oh wow, the problem with that is you can see they come in a bit wonky when they land, so I don't think I'll do that. What I might just do is I might just duplicate the rig. So I'll need a couple more emitters, so let's throw another emitter this side. Let's lift it up a bit. Put it down here. And we need to duplicate the generator as well. So let's change the generator up. Throw that emitter in there. When you duplicate emitters, you want to be a bit careful because you can get symmetrical emissions. You can get kind of exactly the same emission occurring, and it can be obvious and you end up with patterns. But if you want to avoid that, you need to change the seed in the emitter itself. So we click on the emitter, go to the advanced tab, and just chuck in a few numbers, just as long as it's different from the original one. Obviously, I don't think it would have been much of a problem here, but let's see what goes on. Awesome. So look at these little guys. We've got another little army coming in. Oh my goodness. They're going to fight. So yeah, this would be quite good for a battle scene or, creepy crawlies all over stuff. I mean, they are pretty disgusting. And in terms of numbers of particles that you could handle, if you went to sort of a much lower poly version of our Beetle, and in R19 you'd actually have an awesome thing where you'd get the LOD object where you can reduce the poly count of each creature. So if you could have a low poly version of this, so that when you're out here, you can reduce that down. You can do that kind of crudely with the poly reduction tool at the moment, and you can see that drop them right down. And the problem is that's going to recalculate every frame because of the walk cycle I've created, and it might get super heavy. However, that might help later on, or perhaps you set it up with a lower poly object. But also just generally, if you've got things like constraints going on, you might need like more sub-steps and things like that, so the simulation can slow down somewhat. So just things to be aware of, and a few limitations. But you could definitely pump the number of particles here. Like if I turn the generator off and we have these two emitters, I actually turn off the if I go to a crazy birth rate and drop the radius right down. Oh, little escapees. Here we go. You can really crank the number of particles. See that? It's still smooth, like the viewport's perfectly smooth. And yeah, so this is where we're going to wrap it up. This is the end of the Swarms project, and I look forward to seeing you in the next one.